Right, question 16. So we've got 5x plus 2y equals 8, and we've got 2x minus 4y equals 8. If I times the first one by 2, that will make this equal 4y then. So I've got times it by 2, scroll by there into that, so that gives me 10x plus 4y equals 16, and I'll just write the same underneath again. Add the two together, 10x plus 2x, 12x, 16 plus 8, 24. Divide through by 12, x is then 2. We'll then put that into, say, the second one, so in 2, then get 2 lots of 2, take away 4y equals 8, 2 2s are 4, minus 4y equals 8, take my 4 over, minus 4y equals 4, divide through by minus 4, so y then is minus 1. You can then check in the top one, 5 times 2 is 10, plus 2 lots of minus 1, 2 lots of minus 1 is 2, minus 2, 10 plus minus 2 is 8, so it works. Question 17 looks like a tricky one. We'll have information about different bits of this possibly in the formula sheet, we'll have a look. This diagram shows a sector of a circle with a radius x and centre naught. The arc of the circle, PQ is an arc of the circle. The angle there is 120 degrees. The sector is the net of the curved surface of this cone. So if you bend this around, you create this. Arc PQ forms the circumference of the circle that makes the base of the cone. So PQ, P to Q if you like there, at that point all the way around is this value here. Curved surface area of the cone is A, volume of the cone is V, the height of the cone is H. Given that V equals 3A, find the value of H. Well, what can we do then? Well, what do we know? Well, we've got the angle here, we've got H, we have the fact that V is equal to 3A. Does that help us at all with anything at the moment? Well, the first thing we could do is work out what PQ is. Is that going to help us? It may do, it may not. We'll then go back to the original thing, right at the front, which gives us certain information. V is a third pi r squared h, and the area is pi r and L. Now L is this thing, so L is that, L is x. So we know that V, so a third pi, now what's r? R is your radius. So do we actually know what the radius of that is yet? No? Yes? We're not sure. Okay, well we'll just leave it R at the moment then. H, what's H? H is the distance just going upwards, so we have that. And we're told that it's equal to 3 lots of this, pi, r, and then whatever this L is. Well, the first thing that can go is the pi's. We can get rid of one of the r's with this r here, and times the 3 up to this side, so I can then say that H, HR, so still got an r here, times the 3 up is equal to 9L. So again we're sort of still scratching our heads going, right, well, is there anything that we've not used yet? Well, we've not used this 120. Could we somehow use that? Well, possibly we could. Could we work out the distance PQ? Would that help us at all? Well, PQ would be 120 over 360 times by pi d. Times by pi and then d, which is 2x. So that will give me then, that cancels down to a third. So it will be 2/3 pi x. Will that help at all? Well, we've then got that this is the circle going around here at the bottom, and we know that that then is 2/3 pi x, and we'd quite like to work out what r is, wouldn't we? If we can work out what r is, we're getting somewhere to where we want to be. Now we also know what L is. L is actually x, so we'll put that in there, and put that in there. Now we're asking to find out what h is, so h is 9x over r. Well, PQ is that's the distance around, that's the circumference, so can we write the circumference differently? The circumference is pi times d, or pi times 2r, so then your pi's cancel, your 2's go, then we've got r is equal to x over 3. This is a really tough question. If r then is x over 3, we can put r instead here and get rid of that, and put x in its place. So we've then got h equals 9x x over 3. Your x's then cancel, and because it's a double override, it will come up here. So h then is 27. So 27 is there. And you take a deep breath. Question 18. The diagram shows vertical tower DC, horizontal ground ABC, line of elevation here, and we've got the values we need. Calculate the height of the tower. Give your answer correct to 3 significant figures. So, what's the first thing that we need to look at doing? Well, do we know anything? Is there anything similar? Well, this is x here, isn't it? That's what we're looking to find. That's what we want to work out eventually. That's when we know we're in the right sort of place. So, what are we then going to do? Well, we've got 25 metres here. If that's AB is 25. What would BC be then? Could you work that out in any way? We've got angles in here. Anything you can think of? Is there similarity in these triangles? We've got a side and an angle here. Perhaps nothing there, but is there anything else we could possibly work out? Well, we've got this is 25. Could we work out maybe the angle in here? Could I then use sine rule somehow? Maybe. Well, we could work out the angle in all the way across here, couldn't we? Because that's going to be 180 take off 90 take off 28, because there's an angle there. So that'll give you 62. So the whole of that is 62 degrees then. Well, I also know then that 54 and this, so if I add my 54 and my 90 together, that gives me 144. So this here has to be 36, the angle in that bit. So then ADB, that angle has to be 62 take off 36. So 62 take off 36 gives you 26 degrees. So 26 degrees is in here. So what would be good then? Well, if I could work out maybe this side first of all. So I've got this side and this opposite side. Do I know what this angle in here is? Yeah, because I can take it off from 180. So taking off from 180 then gives me 126. So I've then got, after all that, the angle in here. This is the side, the angle in here. This is what we're trying to work out. So it's y over sine of 126 is equal to the sine, is equal to 25 over the sine of 26. Bring your sine 126 up, So y equals 25 sine 126 over sine 26. Then 46.7 meters. So if we've got 46.7 meters, where do we go from there? What does that tell us? Well, AD then, that's 46.7. We know this is 90, and we also know this angle is 28, so I can work out what x would be, because I can use the sine rule again. X over sine 28 equals this value here over this. Well, that's not in degrees. It's 46.7 over sine of 90. So x then is 46.7 sine 28 over sine of 90. So 46.7 sine 28 and divide it by sine of 90 gives you 21.9. That's meters there. Question 19. Solve the following. So a nice quadratic to get your teeth into here. So see if we can factorise first. So 3x and x, it's got to be 1 and 1. You've got to get plus 2, so that'll have to be a plus and that'll be a minus. That gives you plus 3x minus an x, which gives you plus 2x. So x then will equal a third or minus 1. And the final one, which is your vector question, question 20. So 20a part 1. We've got these two values here, a to b then. Well, how do we get from a to b? Well, we go along this and then we go this way, so we actually take 6a, go the opposite way, and then we add on 6b, so going this way and then this way. Part 2, e to f. So e to f is this move here. Well, e to f then would just be simply 6a, because it's the same move from O to a. So 6a in there. Part b, x is the midpoint of BC here. Expressed in terms of a and b, e to x. So the movement here, e to x, what will that be there? Well, we know that e to o, or if we just say e to x then, is the same as saying e to o plus o to b plus b to x. Well, e to o would be 6b, o to b would be 6b, and b to x then, well, that would be minus 3a. So that gives you 12b minus 3a. And then C, y is the point on AB extended, such that AB and BY is the ratio of this to this. Prove that E, X and Y lie on the same straight line. So what I'm going to do here is just drop all this working out here. Part C then. I need to sort of visualise this. AB, y is the point on AB. such that somewhere in here, we don't know quite where it is, such that AB is 3 to BY, which is 2. Prove that E, X and Y lie on the same straight line. Well, E to Y, what will E to Y be then? What are we going to get from E to Y? Well, we're going to go E to O, O to B, and then we'll go from B into Y. Well, E to O is going to be 6B, O to B is going to be 6B. Now, we already know that this here is AB. Now, AB is 3 amounts, so it'll be 2/3 of what AB is before, which was minus 6A plus 6B. So that will then give us 12B plus another 6B on top, which will give us 16B, and then divided by 3 is 2 times by 2, which is, so it's minus 4A. So we've now worked out that EY is that. Well, is there anything I can do there? Is there something that I could show? I could actually factorise out of 4, which will give me 4B minus A. And from my previous work in here, I've actually got EX. Now EX, we worked out that on the previous one was 12B minus 3A. So if we bracket out at 3, that's 4B, take away A, and then they are, so hence parallel, because they've got the same roots, the same vector formula, just times 1 by the other. So that tells them that they're parallel there, and they must be on the same straight line.